So electricity, we're looking then at series and parallel circuits, that's an 8, which is going to be recalled the resistors in series and parallel, and domestic uses and safety. So if we look on our book for that first lesson, what is in here, and this is our source material. All there really is the rule for resistors in series and the rule for resistors in parallel, and then there's just some practice problems. So your starting point, let's pick a nice color, let's go with green. So series, give it your title, plus parallel. Right, that's just going off the screen. Series and parallel resistors. And that's all I do, split it into those two sections. So if you do series, you've got resistance adds. That's it, you just add together. If you've got two resistors in series, you add the resistance together. Okay, if you've got 3 resistors in series, you add the resistors together. Okay, so if you had something like a circuit, so there's resistance 1, we call that R1. That's a symbol for resistor, remember, a rectangle at the bottom, 2 lines, another resistor, R2. Okay, the total resistance, or total, equals R1 plus R2. That's it. You just add them together. In parallel, you could draw a little parallel circuit. So again, we'll do R1. And that just goes up to your power supply. And then we're doing R2, so 2 resistors in parallel. And all you have for this one was that the resistors in parallel is always less than, so I could do it by symbols. So that is the equivalent circuit. So it's less than the resistance, less than the smallest resistor. So it's less than smallest resistor. Whatever the values of the resistors are there, that's a symbol for less than. I'll write this out in words as well. So if that was a mega ohm, a million ohms, this was 1 ohm. 1 ohm is the smallest resistor, so the total resistance is less than 1 ohm. That's all you have. You don't have anything more than that. The total resistance is less than 1 ohm. So total resistance is less than the smallest resistor. Okay, you can do it as a diagram like that, and that's it. That's all you need to know. You don't do any calculation for that at all. All you need to know is that fact that the total resistance in parallel is always going to be less than the smallest one. Regardless of what the numbers are, whatever the smallest one is, total resistance will be less than that, and that's it. In series, just add them together. Nothing harder than that. Right, then the next bit was the domestic uses and safety. So we've got our mains supply, so our AC that we plug into, and then we've got connecting to the mains, and then we've got how our plugs and our wires. Okay, that is all we've got there. So we call that, keep the colors consistent, domestic uses. If you've got any questions as go along, just put them in the chat. So that splits down into, let's go with alternating current, AC for short, alternating current. And you've got in that one, let's see what color I'll use. I'll check the same color actually. Do my graph for alternating. Let's do a nice yellow color. So alternating the current goes up and down, goes from positive to negative. So this is your alternating current, and that carries on. So it goes positive, negative. So in other words, in terms of electricity, the positive here and the negative means changing direction. So in a wire, the electrons just bounce backwards and forwards. They don't go anywhere, they just go backwards and forwards. And what you need to know for this is the frequency is 50 hertz. And the voltage is 230 volts. Okay. Here's why is frequency painful? Come on, you all know the answer. Why is frequency painful? It hurts. I can hear you laughing from here, even though you're on mute. Right, so that is all you need to know for AC, the frequency and the voltage of AC mains supply. Okay, and then how do we use it? We have a plug, we plug it all in. So, draw a plug. So the plug has 3 pins, the earth pin, a live, and a neutral. So, draw the shape of my plug. Looks like this. Yes, I've done A-level art very badly. Picasso would be proud of me. So we've got live, neutral, and earth. Now, if I was clever, I would have the right colors here, but unfortunately I don't. So the live wire is brown. Okay, if you imagine that was brown, not orange. The earth wire is green and yellow. So I'll split that up into green and yellow. You need to know these colors. Okay, so there's your earth wire, and the neutral wire is blue. Okay, know the colors of these wires. Simple question, 1 mark question will be label a plug with colors. Okay, what do we need to know about each one of these? The live, okay, is brown. Better if you've done that in the right color. And it has a voltage of 230 volts. The neutral is blue. Again, use your color, makes it easier. And what do we know about the voltage in the neutral? It is at or near 0 volts. Okay, so basically 0 volts. Okay, for various reasons, it might go a little bit above that occasionally. You can still get electrocuted from the neutral wire. Okay, because it's part of the circuit. And highly unlikely, however. And then lastly, the earth, we'll go with yellow. For this one, earth. Okay, and this one is yellow and green. And what we know about the voltage in the earth wire, it is 0 volts. It doesn't actually do anything. It's only there for safety. And basically, that is all you need to know for domestic uses. So, 2 lessons, series and parallel, resistors in series you add together. Resistors in parallel, the total resistance is just, it has to be less than the smallest resistor. You'll never be asked a calculation on that one. AC, we've got alternating current goes positive and negative, changes direction. You need to know the frequency, 50 hertz, voltage, 230 volts, joke is optional. And the plug, you need to know your color of your live, earth, and neutral wires and the voltages of each one. And the last thing to know about the plug is that it is what it's actually made of. Sometimes they're asked that. The pins are made of brass because it's a good conductor. And it's also solid, so when you plug it in, it's not going to bend, so copper would be no good. And the casing is made from plastic, which is a